Welcome to the final lesson where we'll be talking about decomposition, functions and procedures. This lesson is called Procedural Thinking and it will review some of the technical topics that might come up in the exam. In this lesson we'll look at decomposition again and remind ourselves of its uses and advantages. We'll look at the technical terms around the use of procedures and functions and review a couple of exam topics that could come up. So decomposition means breaking a big problem down into many smaller problems. It has many advantages to the programmer. It makes problem solving easier because it turns a big problem into littler, easier problems. It gives us all the advantages of reusability, which I've reviewed before, but basically it saves us time and effort in our future work. We can test each of the smaller chunks of code separately, and that makes our code more reliable. It makes our main program more readable, at least if we pick good names for our procedures and functions, and that's very important. It aids teamwork because we can split the task between many different members of a team. And it helps the overall programming community because we can share and reuse programs that other programmers have kindly and generously shared with us. We've looked at several examples and I hope you've got the idea of how we decompose a problem, and this will apply whether we're sitting looking at an empty screen or if we've got a bunch of code and we want to break it down into procedures and functions. In either case, we look for natural blocks of code. In general, we try and break it down to the smallest possible tasks and have one task only for each procedure or function. Here are some technical terms which you should now use with confidence. A procedure and a function, they're both blocks of code. We sometimes lump them together and call them both sub-procedures or subroutines. The difference between a procedure and a function is that a function returns a value. In either case, we declare the procedure or function, which means we define the code that belongs inside that procedure or function, and then we can call the function from within our main program, which is just to give its name followed by open and close brackets. Now we've learned a lot about how values are passed between the main program and our procedures and functions. There's two kinds of variables: local variables, which only exist within the memory of a function and disappear from memory as soon as the function is finished, and global variables, which are variables in the main program which can be overwritten by our functions and procedures, and we've learned that that's quite a risky way of writing our programs. A better way is to use parameters and returned values. A parameter is a value passed from the main program up to the function or procedure inside the brackets, and a returned value is a single value passed back by a function back to the main program. So first of all, let's think about what local variables are. Here's a block diagram showing what's happening inside the memory of a computer while it's running a car sim program. In this example, speed is stored as a variable in the accelerate procedure and as a variable inside the brake procedure. These are local variables. This means they only exist while those procedures are running and they do not affect the values in the main program. And as you can see, in this instance, the accelerate procedure and the brake procedure have different values for speed, but neither of them will affect the main program. Sometimes that's exactly what we want to happen. An alternative to using local variables is to use global variables. In this case, the value of speed would be held in the main memory of the computer while the program is running, and both the accelerate and the brake procedure can read that value and overwrite it and make changes to it. And if you've looked at my separate lesson on the car software, you'll know that this can be very risky, and you can have interference between the different procedures overwriting the same variable. An alternative is to use a parameter. I'm just using a single procedure as my example here, the accelerate procedure. So I can send the value of speed from my main program up to the accelerate procedure, where it is caught by the procedure and can be used within the procedure. If I send parameters, remember that I have to send the same number to the procedure as it is expecting, and I've got to send them in the right order. They've got to be the same data type. So the variable that I send has to be the same data type as the parameter that receives that value, though the name can be different. And I can call the same procedure with many different parameters. And having done that, I can return a value to the main program, and that will turn my procedure into a function. So I can send speed to the from the main program to the accelerate function. It will change it and then send the changed value back to the main program and overwrite the original value. Only one value can be sent, and it is captured by a variable in the main program. This gives us much greater control over what the functions of our program do. So a function transforms values into new values. The return value can only be sent once. That's the last command of a function. After the computer sees the return command, it will close the function down, and we can only send one value back. That value will be captured in the main program by a variable, which will thereby have the same data type as our returned value, but the name can be different. Other computer languages offer another possibility, and this might come up in the exam. This is an alternative to using local and global variables. When you pass a parameter to a function or procedure, you can pass it by value or by reference. If you pass a parameter by value, you're sending a copy to the function or procedure, and that is the safest way to do it, because the function or procedure won't be able to alter the values in the main program. Alternatively, you can pass a parameter by reference, and that means we give the function or procedure the address of that value. That's quite dangerous. It's a bit like using a global variable. We're letting our function or procedure overwrite or mess with the values of our main program, and we already know to avoid that. So just as we would avoid using global variables in other programming languages, we would avoid passing by reference. Pipelining is a programming technique where we pass values along a string of functions so that the value that comes out of one function becomes the parameter of the next function. In this picture, I've got two examples, but we could have a whole string of them strung together in a line, passing a value along, so that at the end of the string of functions, exactly the result that we want comes out the other end. The word for that is pipelining. It does come up sometimes in the exam. So to recap, we've looked at the advantages of decomposition, we've looked at procedures and parameters, we've looked at functions and return values, and we've seen the difference between passing by value or by reference. And we've also learnt a new term, pipelining. Make sure you've got notes on all of these ideas. Your next step is to make notes on all of these points and to learn everything we've done so far, because there'll be a test next lesson. It won't be quite as big as the example in this picture, but it will be exam questions. So get ready for that first thing next lesson. Bye for now.